warm welcome to my podcast, Knowing Universe. This is Abhilasha Dwivedi. I'm a science tutor and also a few more things, and definitely a podcaster. It's been a while that I have not recorded anything for my own podcast, Knowing Universe, and I have apologies for that. Today I'm back with a concept of black hole and what exactly is space-time curvature, and it is very relevant to the black hole. Now, a little bit about black hole, how it is formed. Black hole is formed from a mass, a star of larger mass. For example, our sun, which is our life source, is actually a medium-sized star, and it's never going to become a black hole in future when it collapses, whether we like it or not. But yes, it is a certain possibility that it will happen. Not in near future, that I can guarantee you, based on my knowledge, whatever I have. So, but if a star has much larger size, much larger size than our sun, so the life cycle of that star would be that, it will grow, it will mature, because of the fusion reaction, it will have a lot of energy, and it will just go supernova. That means it will just burst, it will blast, and eventually it will become a black hole. Now, black hole is very interesting for us. Why is that? Because we don't know much yet about black hole, but what we know is that everything is singularity. That means nothing is, a different kind of object inside the black hole. And the moment any object crosses the event horizon, that is the boundary of the, black hole, everything becomes singularity. Now, I'm trying to explain this space-time curvature. What is the meaning of that? So Einstein's theory of general relativity states that objects with mass curve the fabric of space-time. So what exactly it means? The three dimensions of the space, that is the length, width, and height. It just combines with another unit that is another dimension, that is time. And because of this, the gravity arises if any object which has got mass and energy will create a curvature. It is often compared with, let's say, rubber sheet, which is the 4-dimension. And if you put an object on it, it will just, bend a little bit, right? Some kind of indentation will be formed there, right? So something like that, the curve will be formed or warping will happen. So that is because of that is called as space-time warping or space-time curvature. So greater the mass of the object, more the extreme the curvature is going to be, and that would be creating more influence of the gravity. So I hope that this concept is clear, that why there is so much of gravity, what is the space-time curvature, and why there is such a strong pull inside the black hole. It is because of the space-time curvature. So 4 dimensions, 3 dimension, and plus 1 time, and that creates a certain kind of fabric that any object which goes inside becomes a part of it, and that is called as space-time curvature. And this effect, is very intriguing. We don't know much about it because, as I said, the moment we step the event horizon where it is going to happen, everything becomes just one. Have we ever tried going beyond that? Never. Can we? So far, no. So these are the few realities that that can show that we are still in very primitive stage where we know about black holes. Now, do we have any evidence that space-time curvature exists? So there is the one which I really liked is called as time dilation. Time dilation is like time will run slower, believe it or not, but it does. So time runs slower in stronger gravitational field. Why? Because the space-time curvature would be stronger there compared to the weaker fields, and that is more noticeable if there is a massive object like a black hole. So that means that there is a very huge amount of gravity present. So this is something which was very interesting for me. As I said, that we have not gone so far inside the black hole, but there is another interesting theory. I did some research on white hole, because the research said, scientists said that whatever goes inside the black hole will come outside the white hole. So this is just an idea. It's not a theory, it's hypothetical, because we don't know if it is really possible, if it is going to happen. So I'll just read what it is said. The scientists, they are Molina and Ninirola, I hope I'm pronouncing their name correctly. So according to their model, they say, quote unquote, that the matter that falls inside a regular black hole would ultimately exit the black hole through a white hole located in a different universe or in a disconnected region of the same universe. Now, has it been proved? No, it's been not. So it sounds very interesting and exotic to some extent, and it suggests that probably singularity does not exist, but we are still looking for the accurate answers. Now the black hole, we always measure, you probably know that anything in the universe we measure in terms of light years, right? The distance is measured in terms of light years. Why is that? It is because the light is the fastest thing we know, right? It moves fastest, 3 into 10 to the power 8 meter per second. Just imagine. And so how much time it will take for the light to reach that particular place, region, will be called as light years. So we have our very own black hole, which is called as Sagittarius A. I think it is very common knowledge, but there are more other black holes also, like Gaia, and there is another one which is very complicated name like QSOJ0313-1806. I don't really know, but it is 13 billion light years away. I'm pretty sure that I will never know if we have reached there. So the smallest black hole, okay, not the largest, smallest black hole is 3.8 times of sun. Imagine, it's 3.8 times of sun. And the massive one is 66 billion times of sun. So these are very interesting facts. There is another fact, probably this is a common knowledge, that all the black holes, they spin, and the fastest spin at 1,000 rotations per second. So like super interesting fact, which I feel, that like enlightened me, was that what will happen if we replace our sun. I felt some kind of closeness to our sun actually after I was doing some research on this topic. So, and that's why I'm saying, all the time, our sun, our sun. So what will happen if we replace a black hole with our sun? Similar mass, of course, not the 66 billion times. So what will happen, right? Because as you know, that sun has a pull, the sun has a gravity pull, and it pulls everything, right? What will happen? What will happen is that because the mass is same, so the gravitational pull will be also the same. So all the planets, as they are moving, will continue to move. Really? Yes. But because it is a black hole, it is not producing energy. It is like not doing fusion reaction, what our sun does, and help us to live. It will be not there, so it will be cold. But the planet would stay in their orbit because because the gravity is completely dependent on the mass of the object. That's the black hole in this. So now the black hole is a very interesting phenomena. No, it's not a phenomena for sure, but it is probably a very intriguing, mysterious object. We have not understood them, and we are still talking about what is inside, and it is more like we are guessing. We don't have any certainty. I really wish that we can have, but I understand that if we go inside, there is hardly a possibility unless we have a white hole, hypothetical white hole, that things come out of it. So when it happens, it will happen. Till then, I will keep doing my research on other topics, including black hole, and I hope to see you soon. Thank you so much for watching. Please follow me on Spotify. Thank you.